burette. In this lab, we use a burette, 8 test tubes, a graduated cylinder,
Top of his class.
potassium hydroxide, copper sulfate, water,
Goggles.
some sticky notes,
A ruler.
and finally, The purpose of this lab was to observe the transformations that occurred when different ratios of potassium hydroxide were added to the 5 milliliters of copper sulfate 8 separate times to see a different reaction based on different amounts of reactants in the 8 test tubes. Then, we measured the precipitate with a ruler. Having prior knowledge of stoichiometry is important regarding this lab because limiting reactants are what determine the features of the precipitant when you make the solution. We filled the first burette with potassium hydroxide and the second burette with copper sulfate. Next, we filled test tubes 1 through 8 with a mixture of potassium hydroxide, copper sulfate, and water. Then mix. Lastly, we let the mixtures sit for 15 minutes and measured the height of each precipitate with a ruler. We saw that depending on the amount of potassium hydroxide present in the mixture, the precipitant was bigger or smaller, lighter or a darker blue. As BBC's article on conservation of mass states, if sodium hydroxide solution is then added, a transition metal hydroxide is formed. They do not dissolve but instead form solid precipitates. That's why copper solution forms a blue precipitate when mixed with sodium hydroxide. We also saw that from test tubes 1 through 4, the limiting reactant is potassium hydroxide, and from test tubes 5 through 8, copper sulfate is the limiting reactant. When the potassium hydroxide was the excess reactant, there was more precipitant and it was less diluted by the water. A lot of errors that could have occurred include inaccurate measuring, incorrect timing, or leakage of the burette. Suggestions for the future to help prevent errors include different tools with less leakage and double checking your measurements or your work.